Right.
Perfect. Okay, so this is work by myself, Lavi, from Lavi from Tel Aviv University, and Shoham from Africa College of Engineering. Okay. So in 2018, we published a paper that was an outcome of the keynote at ISED in Milan, describing the work of the SIG, and it was on design theory. And in that paper, the word value was mentioned 18 times, but there was no definition of what value means. Okay. So yesterday we heard 6 plenary talks, and today more talks, and they were extremely interesting. They talked about very important topics, but it's unclear what the value of these efforts. Now, making the question is not stating that there's no value, but we don't understand the value from the content of these presentations. Another talk that was given yesterday is by Caramello. She talked about different disciplines or objects, and she talked about the bridges between them, and she mentioned that thing in economics, and I asked her, can we replace money by value? She said, yes, it's more general. So I took the liberty to replace other words in that, and this is theory 1, theory 2, and there are alternative theories. So you may consider that in a particular situation you have an issue and you want to resolve it, and you ask yourself which kind of theory would be better to apply in that particular context. Or if you are a graduate student and you consider to go into different schools, then you might think which of the theories I prefer to work on for the next 3 years of my life. Okay? Or a researcher, it doesn't matter. So if we had that invariant or meaning or value, then we'd have to make to answer this question, and I think these are extremely valuable questions. So the goal is to find out what might be this measure that we can use to be able to evaluate these different theories. So the outline would be, I will talk about stakeholder perception, motivating examples. I will talk about system value model, deriving from that theory value model, and give an example, and then conclude. So let's speak about stakeholder perception coming from science, from the history of science. So probably you all know all these criteria that we want a theory to have. So we will value a theory if it explains observations, if it's elegant or harmonious. We believe that the theory tells the truth or represents some truth in the world. The theory is complete, or the potential of the theory to be refuted or to be validated. There are some other interesting criteria which are less obvious. For example, the alignment of the theory with cultural context. For example, heliocentric model with the church. Is it valuable or not? Or the distinction that the theory makes with the observer and observation. This is also a criteria, maybe. And also the practical utility of the theory, which is not really part of standard, let's say, science. Let's move now to the survey. Okay, so there was a survey, and some of you maybe filled it. So I have 31 responses. Let's see a little bit about the demographics. So expertise in design and expertise in design theory clusters around 10, so people are sort of expert to a certain extent. A member of the Design SIG, half of them. Are you involved in design theory research? Most. Are you a researcher? Most. Are you also a practitioner? Half. So, and the number of years of experience, quite substantial. So I talk about really people with experience in what we are speaking about. So I asked about the definition of a theory, of the value, not, by the way, comment. I'm not defining what a theory is or what design theory is, okay? I'm just talking about the value of these objects, and I assume you have a good understanding of what they are. Maybe not, but this is not the topic of the talk, okay? So, definition of the value of a design theory. I got comments from, you see the statement above to a very long paragraph below. I won't go and describe all these things, but I could abstract from them something very interesting, that the value of a theory is determined by serving as a bridge between practice and research. So, some strange way we find the word bridge again, and by being an instrument for researcher and practitioners. Very different than just science perception of what a theory is. Okay, value of CK. So I asked people, what's the familiarity? It's clustered at the high end, so people are familiar, and they gave a very high value to the theory. But for the question, what's the reason? I asked 3 sentences. There were very high-level, abstract comments about why the theory is valuable. I asked people about CDP, corporate design process. There are only 2 papers on that theory. Okay, so you see here, clustered here. Most people don't have a clue what it is. Okay, still, some people said it's very valuable. The comment there were very precise. Okay, so they understand exactly why they put the 10 there. But obviously, the list is sort of not so great. We'll come back to the theory later. Oh, this is wrong. This is miscopy. This should be Subramanian here. So the value of PSI, again, many people don't know what it is. Sort of few here, and some they gave some value. One thing you should understand: you cannot compare the value here to the value before, because these are different theories, different contexts, and the explanations are very different. There is no comparison between value 8 here and value 8 in the other diagrams. But just a comment. Systematic design, Paul and Bytes, more people are familiar with, perhaps taught it or used it. So we see a reasonable cluster around the familiarity and around the value. Again, the comments about the reasons for specifying the value are very high-level comments. And then trees. How many people know trees here? Okay, so the people who answer are more familiar with trees, and the value is also clustered sort of reasonable way. To the question of other design theories, people provided some other examples, and obviously when somebody said their particular additional theory, they are familiar with it and they provided high value. So the results are clear on that side. Okay. Now I ask people to rank the criteria which they think are important to characterize theories and design theories, and interestingly enough, there is a correspondence between them, quite the same. And people also, I mean, you were comfortable, or the people who answered were comfortable in also agreeing to 2 different criteria that are not part of the standard, let's say, scientific. One is heuristic value, so the theory allows you to create additional hypotheses, and ethical implication. It's not part of any theory. Another thing that I want to show you, this is something that was not in the survey, but I started to classify the different criteria into which kind of stakeholders would be interested in these criteria. So some are the scientists themselves, some are practitioners. See at the bottom, society emerges also. So different criteria may be more interesting to different stakeholders, and this is why the value of a theory might be different for different stakeholders also. There's no single value. Okay, now let's do the comparison between theories. So I asked people, what's the value or relative value of GDT and CDP? So people said, I don't know. Obviously, they don't know these theories, but they gave more value to CDP, perhaps for the right reason. But we'll come back to it later, and we'll see some modifications to it. CK and trees. CK is more valuable, but there will be a switch later on, so be prepared. And then systematic design, axiomatic design. Not necessarily you can even compare them because these are slightly different theories, but there was no, and people still, some of them did the comparison. Okay, so what can we learn from this exercise? So if bridge existed, we could have made this comparison in a way much better because it would be much more precise, let's say. The perception of value is subjective. It's rooted in our experiences and familiarity. There was a diversity of perspectives on how to define design theory value as represented in these results and in the text that people provided. Some motivating examples now. Let's compare Newtonian mechanics and general relativity. Okay, so as a representation of truth, Newtonian mechanics is false. General relativity will be false someday in the future. Okay, but still we think that general relativity is better than Newtonian mechanics. It's more general. It's explained phenomena better. But as far as the last three criteria, general relativity is much more complex, hard to understand. So along these lines, then Newtonian mechanics, and certainly in relation to practical utility, Newtonian mechanics is much more valuable. We use it on a daily basis. I don't think any of us use general relativity in engineering practice. So Newtonian mechanics may be more valuable, perhaps. GDT and CDP, so something that you might know. CDP is mathematically more general than GDT. GDT is a special case of CDP. So from a scientific viewpoint, CDP is more valuable. One interesting thing is about GDT. GDT is the only design theory that was reproduced, including all the theorems, by somebody outside the group. Happened to be me in 1995. Quite a significant job. This is why I imagine we don't see such an effort again. But you see here, for example, something that we do not speak about. GDT was extremely useful to its originator. They derived significant fame from the theory, and they are cited extremely well, and people cite it without knowing it really, okay? But it doesn't matter. The value to the originator is significant. The value of CDP to the originator is almost zero, okay? So what's how do you value or the two theories? How do you compare? I mean, it's very difficult to judge, okay? This is better, another is better. CK and trees. If I look at the different criteria, then trees is more well-known, it's spread around in different communities. It has version, it has software tools, conferences, adaptations. It made its originator famous globally, more than the originators of CK. But it has more citations, but maybe time will change that. But I would say that trees is more valuable than CK, considering all the stakeholders involved. So what I want to suggest by now is that the examples that we saw so far about how value of theory is perceived by different people, how the different examples demonstrated, is really a sort of annual. It's a problem. It's like a black swan to the people who want to think about theory value concept. So when you have a black swan, you have to design. So we need to design the theory value. Okay. So far we couldn't come up with something that basically is a bridge, is a general bridge that we can use. Then we need to design something. Okay. So now the process is, let's design a theory value. So I'll start with a system value model, and then from it I'm going to show you what the theory value model is. So, value concept in system. From my experience, when I talk to stakeholders in project and research project or actual project, they cannot tell me what the value of, let's say, a certain property or a particular task that they are specifying, what the value of that thing is for them. So the concept of value is something really outside the language of most practitioners. I mean, they speak about the value, but they cannot articulate what the value is. And if you look at the literature in system engineering, product development, project management, whatever, many papers have the word value in them, like the paper that we wrote in 2018, but they don't specify what value is. Some do, they speak about monetary value, how much profit we are going to make, and they speak about how much we spend on the project, and then they want to compare these two, and this is the value or the cost-benefit value of the project or system or element, but there's nothing more than that. We then turn into other domains, so we looked at law and healthcare, education, and we see people in these disciplines are expanding the way that they think about value. So we wrote a paper on that, and from that we sort of came up with this particular definition, that the system value is the system life cycle holistic impact encompassing the multi-domain effect on processes, environments, and stakeholders. Let me show you some example. So if we look at, let's say, system development project, each stakeholder in the development process see the project in a different way. So the design team is focusing on the innovation. Their value for them is the innovative aspect. And then the system engineer is looking for the performance. The QA is looking for compliance to the requirements. So each stakeholder, their value is from their own perspective, and there's nothing that integrates everything. Another thing that is interesting is as along the system life cycle, the value of the system changes. It can go up, it can go down. Certainly at the end, it diminishes. So it's not a particular value, but it can be the same for a theory. Okay, so a theory can be developed, and initially it's sort of, let's say, state of the art, and sometimes competing theories emerge, and the value of the original theory may diminish. But this property of value, the value the change is important to realize. The way that we conceive the concept is that we look at the different beneficiaries or the stakeholders, and for each of them we define value cluster, and for each of them value element. We initially started, we had about 150 value elements, and we started to cluster them because something like this is incomprehensible and impossible to use. So we ended up eventually with 30 value elements clustered in 10 value clusters for 3 stakeholders. And I'll show you just the top level. So we are looking at customers of the system, society at large. These are people beyond the customers, or the people who are going to actually use the system. And the enterprise, this is the stakeholders that develop the system. So for each of them, for the customer, there is operational, economic value, emotional value, social value, society well-being, economic, ecological, and enterprise structural, financial, human capital, and relational value. So for each of them, there were some clusters. We took this model and we applied it to several cases. We wanted to broaden ourselves beyond the technological systems. Then we look at the strategies, we looked at the requirements analysis, alternative, comparing between alternatives, and we ended up seeing that the model allows us to understand, or at least interpret, or even perhaps would have allowed us to forecast certain events before that using the model. And I now teach it to students, and they apply it in their course project from the beginning to end. From the beginning, they apply it in the conceptual design, and as the project progresses, they apply it later on to see whether their decisions are deteriorating the value or not, or they can make certain changes to improve the value, and so forth. So moving to the theory value model, we change very few things. So emotional value is now expressed in the beauty and elegance of the theory. This is one criteria that was there before in science in general. Operational value is based on the contribution of theory to theory or practice, impact on the field, basically the practical utility of the theory. And relational value is stated through the university ranking or journal impact factor. For example, if I'm publishing in a journal a theory that attracts citations and reputation, then the reputation of the journal increases, or the reputation of the university increases, and this is a good value that the theory generated. So let me show an example. So the process is we start, and the example is I'm trying to evaluate PSI. So we are starting by giving the core values and the goal of PSI, and then we do an analysis of the stakeholders. This is again in PSI basically philosophy. So we are asking ourselves, for the customer, these are the stakeholders that are going to use the design theory. We're asking, what are they going to use the theory for? So that they might be analyze complicated design scenarios. Now we're talking about PSI theory. The PSI theory, for what do people are going to use it? So they are going to analyze complex design situations. Who are going to be involved? Design practitioners or managers, and how they're going to bring various aspects of designing, including interconnection, into a single meta model using PSI. Okay, so we take each stakeholder. These are the stakeholders, and we make them more concrete here, and ask what are they going to use the theory for, and how they're going to use the theory for. And with that, then it's easier for us to evaluate the theory. So here is the value model applied to PSI. So here is the customer, and here you see the emotional value, operational value, economic value, social value. These are the 4 clusters that appeared below. And here there are some more refined, these are the elements. So we have 10 elements for each stakeholder. And there is the explanation. So for example, here, there are 2 columns. In one column, I'm specifying if this criteria or element is relevant to this particular theory. Sometimes it's not relevant, so it will be 0. And then I'm ranking it between -2 to 2 to be able to use something like this in the, let's say, initial stages of evaluating. I need something qualitative. I cannot give real numbers. So looking at what we have here, for the users of the theory, let's say it created quite a high value. For society at large, I'll just show something here. One of the criteria is environment asset preservation. So what's the impact of the theory, let's say, on the environment? And PSI is not necessarily directed to that, so we marked 0. And so the value is obviously 0. But something like this, when we evaluate a theory like this, then it's an opportunity to change the theory. Let's see if we can come up with a modification, let's say to PSI in some way, that this element would be relevant and would rank high. So this is an example that by having such a, let's say, a checklist about when the theory is relevant or not and what is its value, we can direct future effort to further development of the theory. And this is, let's say, the enterprise, the body that develops the theory. What's the value to this? Here is also 0. Revenues, yes. PSI doesn't provide any revenues for us. We have to think about it, but here it's concrete representation of that. Okay? Okay, so we can take this particular model and apply it to different theories, and then we can compare the different theories. So this model is really sort of a general bridge. Not only that, we can look at the evaluation of different theories, and let's say one theory is better for the customers, one theory is better for society. So really, there's not a real basis for comparison, but we can use both theories if we can want to provide value to different stakeholders. So it's not necessarily that this is to resolve competition between theories, but if we want to provide really comprehensive value to all the stakeholders, we might consider taking several theories together that complement each other, and we have a more valuable complete setup. Okay, so I presented theory value model, and of course you can ask, what's the value of the theory value model? Okay, so no problem, apply the theory value model to it. We actually didn't do that, but for the system value model that I described before, we apply the system value model to it. Okay, and we derive some modifications. So for me, this is a standard process to do such reflection, to apply tools to themselves. I wrote about it in 2017, the principle of reflective practice, yes. Okay, so this theory value model enables a holistic evaluation of a design theory. It creates improvement opportunities, as I said. If a theory is ranked low or something is irrelevant, we see immediately where is the opportunity for improvement. And if we want to improve it, then we ask ourselves, what will it take to improve it? And if there are several things we want to improve, then we ask ourselves, what's the cost-benefit value to address, let's say, one before the other, and so forth, or do not address at all because it's just too much work and the added value is minimal. So It's not just an evaluation, but it provides guidance. And it's also, as I said, theory selection mechanism, enable stakeholders to use different theories for particular purposes. And last, I use the word scaffold, but you want to use the word bridge as we saw. So it's sort of a bridge in design theory, which can be used, I think, to further the progress of the field. Thank you very much.
Thank you. So we have some time for questions and comments.
Thank you. That was interesting. I always thought of your theories as describing the design process, and I see now you want your theories to be used by actual designers. And then there's a question that would have been
That is
hard
not
to ask.
confirmed.
If you
We
think
can
that
only
there are
confirm after
several
we-
100,000 design teams, how many of them are working with a theory? I mean, how much is the theory guiding their own practice? Or do they have practice that they've developed, practice principles they've developed by the domain they're working with, the group they're working with, and so forth? Because I would
Let me
imagine
think
that,
about it. My brain is not.
I would imagine the latter, but maybe you have some
No,
thoughts on that.
it's a fantastic question, and what it allows me to say is when some people, for example, say you go to university, you learn the theory, you learn the basic, and then you go to industry and you learn how to do stuff. And I tell them industry have no clue about how to do stuff properly. I mean, staying in the university, you learn how to do stuff also. Practice has a underlying basis, and I think that the students who get out from, let's say, my classes or similar classes, they become ambassadors of how to do things properly. That's, so industry doesn't use these things, not theories, not even proper tools. Many industries don't use the classic design tools.
Again, thank you for illuminating this area, which is quite difficult, I think, to come to grips with. But I'm not sure I agree with your wholehearted damnation of practice. You do know the aphorism that in theory and practice are the same. In practice, of course, they're not. But Donald Shoham spent a lot of the last 20 years of his life trying to enunciate the notion that practice knowledge generates something different than theory. That when you practice, there's behind it something that you're developing through practice. And I think that's sort of the failure of people like us who work at the more conceptual level, that we don't try and get hold of that in some way and integrate that. Now, I'm not sure you have to agree with that, but Donald Shoham was very explicit, and it's interesting because his lectures are now being put up on YouTube, so you can actually listen to what he said as opposed to what people said about what he said. And he's a whole notion that there's a different kind of knowledge which isn't to be thrown away.
I completely agree. I didn't say that at university you just teach these things, but if you, let's say, get students through a project-based learning, and you teach them the theory, and then the students actually apply it in a real project with actual stakeholders outside, then they can get a sense of that and get the sort of theory or the tools with that particular experience that is created by practice. what I meant, let's say, in industry, obviously they do things, but I talk to people, let's say, in serious places in Israel, and I ask them, how do you, for example, evaluate your candidate designs? And the only way that they do it is by list of criteria and giving numbers, weights like 1 to 5, which is, in my view, the least or the worst way to come up with alternative. Nobody knows what AHP is, for example. So, to me, there's lack of knowledge in industry about certain tools that are people must know. And, obviously, they practice, they do stuff, but I mean, we encounter the results of their designs every day, unfortunately.
I want to elaborate on that. In Tel Aviv University, I have a special program.
Put the mic so
Sorry. There's a special program that takes excellent students of engineering and teach them something like a quarter of the BA in humanities in order to develop high level of abstraction, conceptualization, and other skills that they need, that we think they need in the practice. So what I'm trying to say is that I think that during teaching those theories, you're not design theories. You're not just teach them how to practice or how to implement the theories. You are, of course, trying to teach them what is the rationale behind theory, or what we're trying to achieve in the conceptual level and not just in the practical level. And I think that engineers are doing the same at practice. They are, though they are concentrated on the practical issues that they need to solve or develop, if they are properly educated, then they have the ability to have a reflection of what they're doing, and maybe though they are not using specific theory by the book, elements of theories are vividly there in what they're doing. So I think I'm trying to okay, and then this we try to develop a tool that will help us look at design theories and trying, to make some measurement and not seeing them separate or incommensurability in Kuhn's sense of the word. Okay, so that's what I'm trying to say.
Thank you. Maybe time for the last question. Comment, please.
Thank you. I hope you'll indulge me a perverse question. When you set out there at the beginning and kind of inverted Olivia's money value relation to concentrate on value. In listening, I was wondering if in fact money now shouldn't invert value in thinking this through. True, things are not necessarily generating revenue. But one of the things that is valuable here is the sustainability of the design practice. And how are you going to do that in a context where universities have fewer and fewer resources to help sustain those things? I mean, you're appealing to vendors, you're appealing to organizations that want to know, well, why would I support that? And you've given them 100 good reasons why they should think this is something they want to invest in. But that's about money. That's not revenue. It's not like you're making a patent and you're profiting from that. But you're sustaining an activity. that's valuable to be sustained as such. Okay? Isn't that about money? Now, we're in a neoliberal world where these phenomena are sort of ongoing.
Well, I think there are things that you cannot translate to money. For
I
example,
didn't say that. I mean, in order to do what you do,
yeah.
how do you sustain it?
So first, I'm in an educational setting, so I teach these things to students, and I hope that when they come out of school, they will continue to teach it and become to use it and become ambassadors in their places and
I see that.
propagate it. But I do, for example, this thing about the system value model. Let's say the second author is working in a company that you might have heard in the last I don't know year because of the war, and this is a big issue also. So how to put a value on what you do is something that they are not familiar with, and this is why they may, for example, create requirements that are over specified. Or create requirements that are not necessary, or ignore certain stakeholders that the system can provide them significant value. So I think that a model like this, a model like this would be extremely valuable to them. So we are looking into how to implement it in her organization now.
Fair enough.
Okay, thank you.
Well, if I may, to respond, just I was a student of during my master's, and I tried mostly to apply most, if not all, the theories and frameworks that we learned during the studies into where I worked. The thing is that, as you said, companies are more interested in time and money. So, in a way, I can say that we were doing things wrong. We were making a lot of mistakes. We were going way away from what the theory was telling us to do, and we were doing it wrong. It brought a lot of problems, it brought a lot of reworks, and at the end, I think that what interests companies is things that are cheap and easy to understand. So the digital way of the transformation of the design theories in a digital way will be, I think, the key to all of that. Same thing for industrial systems are very. NDAC is really complex for companies to implement it, but it's really useful. So we need to find ways to make it easy, like for children, or to implement theories, because like it started.
Sorry to interrupt. I mean, in the last talk, I didn't give the possibility to say something, so just very short.
Thank you, Yura. Don't you think that in the industry, in the companies, there are very often implicit theories, because there is no practice. In practice, there are very often old theory which are forgotten as theory, and which are there. The difference is not just between theory and no theory, but between theory that is known as theory and theory which is not. And this is a problem when your practice ignore the theory which is embedded and which is forgotten, because this is a tendency to fix the practice. So what is important in the theory is that you know that it is a theory, and then you can change it.
So I'm not sure that I understood the question, but what I spoke about is not necessarily for a theory, let's say scientific theory or design theory. If you have your own theory, you can still put it in and look at the stakeholders and see which kind of stakeholder your theory support and which are not, and then you understand what the value of your theory is to these stakeholders, and you will get significant insight out of it.
I'm sure we might continue for hours, but I need to close this session. I would like to thank, of course, Jacob, Shoham, and York for the nice talk. Thank participants in the session and speaking to the workshop, but last greetings from the Design Theory leaders.
self-disclosing.
Okay.
I want to announce two things.